Hello, everyone. Let's go ahead and go over SPSS one-way repeated measures ANOVA. So in this particular question, they're looking at different interrogation techniques to see how they influence the memory recall in witnesses. 15 participants were exposed to three different interrogation techniques, which were neutral questioning, which was factual non-leading questioning, leading questioning, which is where they suggest possible details, and stress-inducing questioning, which is pressuring participants to answer quickly. Each participant viewed a simulated crime video and, after a 20-minute delay, was asked to recall details using one of the three techniques. The order of the interrogation techniques was counterbalanced across participants to reduce order effects. The process was repeated until each participant experienced all three interrogation techniques. The number of correct details recalled in each session was recorded, as shown below, by interrogation technique. Data are in the data file. Your job is to answer the following research hypothesis. Does the type of interrogation technique influence the accuracy of memory recall in eyewitnesses? So I don't know. Let's see what's going on. So again, what makes this repeated measures is each person was questioned under all three techniques. They just counterbalance the order in which they did them. So some people did neutral first, then stress, then leading. Some did leading, then neutral, then stress. Some did stress, then leading, then neutral, etc. All possible combinations. So how many interrogation techniques are being compared in the ANOVA? There's one, two, three. Is the research hypothesis above two-tailed or one-tailed? So does the type of interrogation technique influence the memory accuracy of memory recall in eyewitnesses? As a two-tailed hypothesis because they're simply saying, hey, well, is there some sort of effect here? Not the direction of the effect. They're not predicting that this is better than that or that's better than that, etc. So it's two-tailed. So to write our hypotheses, we've got the mean of group one is equal to the mean of group two is equal to the mean of group three. That's our null. Our alternative is an omnibus test, is that they're not all equal. So the mean of group one is not equal to the mean of group two is not equal to the mean of group three. There's at least one difference. So let's go ahead and check our normality assumption. And to do this, I suggest that you go to the explore procedure. So to do that, you go to Analyze, Descriptive Statistics, and Explore. And in there, we want to put all three of these in the dependent list. And I think under statistics, we are already going to get the one we want. So we can just click OK. And there's our output. So for neural, our neutral questioning, leading questioning, and stress-inducing questioning, you've got a skewness coefficient for each one of those. And the question we ask ourselves is, are these all less than an absolute value of 2? That one is, and that one is, oops, that one is, and that one is. So for all intents and purposes, we would say these data are basically normal or normal enough. So does the data appear to meet the normality assumption? The answer is yes for each group, for each level. So now we're actually going to go ahead and run our one-way repeated measures ANOVA. To do that, we go to Analyze, we go to General Linear Model, and we go to Repeated Measures. And then in there, you have to set up a variable. The default is factor 1. So what I suggest you put in there is interrogation technique. So I will copy this and put it over there. And interrogation technique has how many levels? Well, there's 3 of them. Click Add. What did I do wrong? Do I have I got an extra space at the end. There we go. Click Add. And it's ready. So now we click Define. In this box, it's created 3 separate variables. It wants to know those are the levels of what. So we are to match over these variables in the following order: neural, leading, and stress-inducing. Neural, leading, and stress-inducing. That's our three levels. Under plots, you need to take interrogation technique for the factors box and move it to the horizontal axis. Make sure you click add. Then select the button for y-axis starts at 0, right down there, and click continue. Under the options button, you want to get the usual things, get descriptive statistics and estimates of effect size. We're skipping homogeneity tests this time. And continue and OK. And that should be it. All right. This is our repeated measures ANOVA right here. Excuse me. So first thing is ignore this multivariate test that was in the lecture. You're just supposed to get the means and standard deviations for the number of details correctly recalled under the three techniques. So it's 9.8 details correctly recalled for neutral testing, the standard deviation of 1.82. For leading questioning, it's 7.07 with a standard deviation of 1.53. For stress-inducing questioning, it's 13.73 with a standard deviation of 0.96. So we do want to test the homogeneity of variances, covariances assumption, otherwise known as a sphericity. And to answer that, we look at Mauchly's test of sphericity. So again, we skip this multivariate test thing. Go to Mauchly's, and this is kind of like the Levine's test. We don't want the significance to be greater than 0.05. So scooting on over, there's our sig for our Mauchly's test. If this is greater than 0.05, we have met the singularity, excuse me, the sphericity assumption. And indeed, that is greater than 0.05. So to answer the question, using alpha 0.05, does the data appear to meet the homogeneous variances, covariances, sphericity assumption? That is, it's Mauchly's sig in the interrogation technique row, this row, greater than 0.05. Yes, it is. We've met the assumption of sphericity. So now we want to fill in the goodies for our Mauchly's test. Goes in our write-up. We have a Mauchly's W of 0.96, which is the equivalent of a chi-square with 2 degrees of freedom. And sample size, total sample size is up here. There's 15 total people under each condition, same 15 people, so n is equal to 15. And our approximate chi-square is 0.58 right there. The p-value is greater than 0.05, and that is our Mauchly's filled in. So based on that answer down here in the test of within subjects effects, what row should we interpret? Well, we have met the sphericity assumption, so we will use the sphericity assumed interrogation technique and the sphericity assumed error. All right, so sphericity assumed is the answer. So there's our decision rule. We reject the omnibus null if the sig for interrogation technique is less than 0.05. And indeed, it is less than 0.05. So to answer number 8, using alpha 0.05 to test within subject's effects table and the sig value shown for the independent variable interrogation technique on the appropriate sphericity assumed or greenhouse geyser row. We decided sphericity assumed, greenhouse geysers when you violate this. Should the omnibus null hypothesis be rejected? Right there, it should be rejected. That means the number of details recalled under one of the techniques differed from at least one of the other techniques. Could be they all differed, just like the other ANOVA. Could be just one differed from one of the others. Who knows? So we have to follow that up with some additional post-hoc tests. But at this point, all we know is that, yes, there's a significant difference. So yes, why or why not? The sphericity assumed sig value is less than 0.05 for number 8A. So calculating the proportion of variability accounted for. So there's our formula, sum squares for within IV divided by the sum squares within subject's total, where the sum squares within subject's total is equal to the sum squares of the within IV divided by the sum squares within subject's error. So that is this divided by this plus that. So let's go ahead and do a little bit of math here. So let's get the bottom first. Sum of squares total is 336.933. That is that sum of squares, plus 57.067. 57.067 is equal to an even 394. That's kind of interesting. So 394 is what's on the bottom of this. The top is 336. So 336 divided by 394. Let's just go ahead and do that. So 336.933, that number right there, divided by an even 394. And that gets us 0.85, which is not the answer that is here. So 0.85. All right. And let's just see if this thing works. Yeah, partial eta does work out. It gives you 0.855. So technically, if you were just using this, you would say 0.86, and indeed it is 0.86. So I'm going to round that sucker up. And it's obviously wrong down here too. I don't know where I got 0.99. Anyway, so 0.86. So the proportion of variability that in the dependent variable that's accounted for by the independent variable is 0.86. So now we want to fill in our F value using the formula here. We have an F with 2 and 28 degrees of freedom was equal to 82.66 right there. Our P was less than 0.05, and our partial eta squared was equal to 0.86, as we indicated right there, 0.86. All right, well, that's cool. So we know that there's at least one difference between the details recalled under the three different techniques. We want to scoot down now and fill in our ANOVA summary table. So starting over here, our sum of squares, which is totally wrong. So, oh, error, it's not totally wrong. Good Lord. So it starts out with our between subjects error up top. That is down here, 35.20, 14 degrees of freedom, mean square of 2.51. That is these numbers right here. Note it's between subjects effects. These are tests of between subjects effects. Then for within subjects effects, we have for our independent variable, 336.93, 2 degrees of freedom, mean square of 168.47, an F of 82.66 gets a star because the sig is less than 0.05. And let me fix this to 0.86. All right. The error within is 57.07, 28 degrees of freedom, and 2.04 is our mean square. And then for our total, we want to total, in this case, the whole column. So let's go ahead and do that. We got 35.20 plus 336.93 plus 57.07. That gets us 429.20 right there. And our total degrees of freedom for the whole thing is 14 plus 2 plus 28, and that is 44 right there. Given that the null hypothesis was rejected, what can we conclude so far? Well, at least one of the means or the interrogation techniques resulted in recall that was different from at least one of the others. So something along those lines. I said mean recall for at least one interrogation technique, different from at least one other. Now we have to take our means plot and turn it into APA format. It's pretty close, actually. So let's go ahead and double click on it to make it APA format. So a couple things we want to do is get rid of this title. So you click on it, hit delete on your keyboard. That gets rid of it. Other thing we want to do is turn this into what the actual dependent variable was. That is mean correct details recalled. So mean correct details recalled, something like that. get a little poetic license with those sorts of things. Want to get rid of these lines, so you go under Options and Hide Grid Lines. Down here, 1, 2, and 3, we actually want to fill those in. So this first interrogation technique was neutral questioning. Neutral questioning. The next one was leading questioning. And the last one was stress-inducing questioning. And finally, we want to make this an actual word because currently it's just a squished together mess. Interrogation technique, throw a space in there. So you got some options with other things. That is sort of the bare minimum you need to do to make it APA format. I do tend to make sure everything is at least 12 font for my own sake. Sometimes I'll get rid of decimals. In this case, it does go up half a point, so I'll leave it. This is 14. I'll go back down to 12. And that is 14. And I'm going to make this 14 too, just because I think it looks better. All right, I close that. We've got ourselves an APA format plot that we can put into our APA template. Found the best way to actually copy it isn't from here to copy, but to double click it and go to edit, so copy chart. That gets you a better paste version for some reason, sometimes. All right, so at least one of these differs from at least one of the others. Kind of looks like stress-inducing questioning was the most resulted in the best recall. Who knows if these two differ? Maybe they do, maybe they don't. But what we have to do is do a bunch of paired sample t-tests in order to compare each one to see where they differ. So we've done these before. Go under Analyze, Compare Means, Paired Samples t-tests. We need to match up each one to each other one. So the first one is neural versus leading. Then we want neural versus stress-inducing. And then the final one is leading versus stress-inducing. Those are the three possible. So neural versus leading, neural versus stress-inducing, and then leading versus stress-inducing. So click OK to run them. Here's our paired samples t-test. So in order to interpret these, we need a Bonferroni corrected alpha level. Bonferroni corrected alpha level is 0.05 divided by the number of tests we're doing. So we're doing 0.05 divided by 3 tests. We get 0.01666, etc. So we'll round that to 0.017. That is the new alpha level we will use. So 0.017 is the Bonferroni corrected alpha level we use to interpret these paired samples t-tests. So for the first one, let's see what's going on. So, oh, this is easy. So for neural questioning versus leading questioning, they significantly differed. We got to use two-tailed. For neural versus stress-inducing, they significantly differed. It's less than 0.017. And finally, for leading questioning versus stress-inducing, they also significantly differed, less than 0.017. So to interpret them, so we know each level differed from each other level, I look at the picture and I say, okay, so how did neural versus leading? Neural was higher mean than leading questioning. So neural was greater than leading. Neural resulted in greater detail recall than leading. How about neural versus stress-inducing? Neural differed from stress-inducing significantly. Neural was less than stress-inducing. So neural less than stress-inducing. The final one down here was leading versus stress-inducing. Leading versus stress-inducing. We know that this significantly differed too. Leading was less than stress-inducing. Leading less than stress-inducing. So what's it kind of mean? Well, putting it all together, this is where I used to say, what would you tell grandma? You'd say something along the lines of, Well, stress-inducing questioning led to the greatest recall, followed by neutral questioning, and finally leading questioning. Most effective, second most effective, least effective. Stress-inducing questioning resulted in the best detail recall, followed by neutral testing questioning, followed by leading questioning. So best, second best, last. Finally, if the data had been ordinal, severely violated the homogeneity variance assumption, or the sample sizes were very small or unequal, what backup test could you have used instead? To answer that, I'm going to pull up the matrix of statistical tests, and we're on this bottom row with interval ratio data. Find one-way repeated measures ANOVA. There it is. And the backup test is always the one above it. That is Friedman-Rank's test. Friedman-Rank test is the backup for one-way repeated measures ANOVA. So Friedman-Ranks. That's it. So you just got to write that up using the template and it should be good to go. So hopefully that was helpful.